Hey guys, welcome to Sigma notation. Okay, so when we want to add many terms together, take the sum, we use sigma notation. So, sigma notation, Greek letter here, E, okay, so this is our definition when we want to add. This is telling us to take the sum. Our first value of n is at the bottom, n equals 1, it's where you start, okay, and the last value of n is on top, where you finish, okay. This term here, whatever it is, and just so I just put n squared here, is what you're adding up, okay? It's basically what you're plugging all these numbers into from start to finish into and taking the sum, okay? So we're going to do several examples where we use sigma notation or write a set of numbers, a set of terms in sigma notation. Now, there are three basic rules with sigma notation, okay? So C is any constant. So for example, we go from from m to n of c times a sub k. The c can just be pulled out front and we can add up our terms from m to n of a sub k, excuse me. Okay. Second one deals with adding two. If we're adding two terms together, we can basically separate those two terms individually and take their sums from m to n individually, then add them. Same thing with subtraction. You're going from m to n, and if it's a sub k minus b sub k, we can split those. Sorry about that, the board there. K equals m to n. You can split those individually. Okay, separate them and take the sum individually, then combine them at the end. You don't always have to, but these are three rules that we can use to help us when we take and use the sigma notation and try to find a sum. We can separate them to help us find that sum and make it a little bit easier on ourselves. All right, in example 1, evaluate the sigma notation from 2 to 4 of 2k plus 1. So this is, we're starting at 2, we're ending at 4, and we're using this to plug in the values in between, okay? So we're going to add up the terms from k equals 2 to k equals 4. Okay, we want to know the sum when k equals 2, 3, and 4 into this formula. So here is the 2k plus 1, 2k plus 1, 2k plus 1. So here's our first term, second term, third term, all plugged in from 2 to 4. Okay, and they're integers, okay? So then we get 5 plus 7 plus 9. So that equals 21. So the sum of this 2k plus 1 from k equals 2 to 4 is going to be 21. Example 2. Now, instead of giving something in sigma notation, we're going to write the sum of these terms in sigma notation. So, I write my sigma, okay, and then I notice my first term I start at 2 and I go to 10. Now, the reason I do that, because if this is, if we had, like, let's say we went 1 over 1 was the first one, right? It's not, because we're starting at 2, but this is the general pattern. First term, second term, third, fourth, fifth. So whatever term I'm on, that's the denominator. So sigma notation from 2 to 10, and it's 1 over n, because the numerator is always 1. Okay, I started at 2 and I ended at 10. So this is the sigma notation that represents the sum. Okay, didn't ask me to find it. I just wanted to know what the notation was. All right, example 4. Actually, it should be example 3. Oh, I had them backwards. That's okay. So we'll go with example 4 first. This should be the new example 3. All right, so find the sum from 2 to 5 of 1/10 k cubed minus k squared. So in red, I separated the two. I took the 1/10 out front, and then I separated the two terms into two different notations. So you can see in blue is the one on the left, and in black is the one on the right. I looked at them separately, combined them at the end. So 1/10, so from 2 to 5, I plug it into k cubed. So 2 cubed plus 3 cubed plus 4 cubed plus 5 cubed. Okay? Minus 1/10, and now this is squared, so it's 2 squared plus 3 squared plus 4 squared plus 5 squared. Sorry, the printer is going. So I go ahead and simplify. I get 2 cubed is 8, 27, 64, 125, and I square those out. And then I combine them. I get 1/10 times 224 minus 54 and I get 17. So that is the sum. In our last example, our new example number 4, okay, write the sum. 1/2, 1 plus 1/4 plus 1/8 plus a 16th, dot, 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 continues on until you get to 128 in sigma notation. So I rewrote the pattern here. And I noticed my first term, 2, 4, 8, 16, 128, those are all exponential, 2 being raised to some power. So the first one is 2 to the first, 2 squared, 2 cubed, 2 to the fourth. So my first term is 2 to the first, second term 2 squared, third term 2 cubed. It's going to be 1 over 2 to the n, and n is the number of terms I'm on. And it's 1 to 7. I started at 1 and I ended with an exponent of 7. Okay? So, those are several examples using sigma notation. If you guys have any questions or comments, go ahead and type them below. We'll see you next time.